Here's a fourth example. This is a scanning electron micrograph. These scan the surface, and they allow you to see some structures in 3D. Scanning electron micrograph images can be tricky. Again, it's important to identify something on the bacterial ruler. This image is of cells in the respiratory tract in the lungs that have cilia. I've hidden the scale bar down in the lower left because I didn't want you to see it yet. Based on the caption that came with this cell, some cells have cilia. All these little hairs here are cilia, projections from the cell that can wave back and forth and help move mucus and particles out of your lungs. The spaces with none of those little hair-like structures, the cilia, those are the surfaces of non-ciliated cells. Non-ciliated cells produce some of the mucus that helps trap particles and bacteria to be moved out of your lungs. Here are my questions. How long is a typical cilium, and how wide is a typical cilium? Pause here if you want to work on this before seeing my answer. Some of the cells are ciliated and some are not. The regions with no cilia might be single cells. The double arrows I've added might indicate the size of one cell or two cells side by side. So now we need to make a size estimate. The double arrows, except the long one, might be about the width of one cell, about 10 microns. Step 3, we apply multiples or fractions of our estimate. None of the cilia seem quite as long as the double arrow. Most seem to me to be about half as long. So I'll estimate that the cilia are about 1/2 times 10 microns equals 5 microns. So the cilia are maybe about 5 microns long. And how wide is a typical cilium? It looks like the width is less than 1/10 the length of the double arrow. If I, in my head, added up a bunch of those and widths all the way across, 10 of them wouldn't be enough to do it. The width might be about 1/20th the length of the double arrow. To me, if I added up about 20 of those tips, it might get there, but they might even be less. So 1/20th times 10 microns equals 0.5 microns, 500 nanometers or less. I'll estimate about 250 to 500 nanometers. How well did we do? This figure had a scale bar. I've uncovered it below in the very bottom left. It's pretty small. If you can't read it on a smaller screen, the scale bar indicates 5 microns. The long, thin line is about 5 microns long. I've added a thicker line, the white bar, that's the same length as the 5 micron scale bar that came with the image. That shows what is 5 microns. We were pretty close. Our 10 micron double-headed arrow is probably closer to 7 or 8 microns, but it's not very far off. So our estimate was certainly within a factor of 2. Now go on to watch the next video or practice more problems on your own.